is help with pouches and coins and solving equations if you're a little stuck. So I'm looking at the ACE problem from 3.2 and 3.3. This is problem number 5 on the second page. It says for problems 5 through 8, write an equation for the picture and find the number of gold coins in each pouch. Use an X to represent the pouches, because we don't know what they are, so we often use variables in math to represent things we don't know, and a number to represent the number of coins on each side. So if we wanted to write an equation, we have 1, 2, 3, 4 X's plus 2 coins, so plus 2 on this side, equals the amount of coins on this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Sounds pretty good. So if we go back to pouches and coins instead of our equation, we know these work like they're on a teeter-totter or on a balance like maybe you've used in science. So they're even right now, they're balanced, they're at a level amount. If we took something off, like this coin, it wouldn't be balanced anymore. So if we took this coin off, this side would be heavier and it would tip, and this side would be lighter and go up. Since it's balanced, we know that the amount of coins on one side has to be exactly the same as the amount of coins on the other side. So since we know there's 18 on this side, this has to represent 18 as well. It's just that some are hidden in pouches and some are not. So most students said, well, I know I can kind of get rid of these two and not worry about them because I know those two aren't in pouches, so it's kind of like those two aren't in pouches. So when we get rid of stuff in math, that's takeaway, right? So we took away these two, and we took away 2 from our 18. So left on this side of the balance is 4 pouches, so in our equation 4x. And left on this side of the balance is 16 coins, because we took 2 away. Then most students said, well, I can make groups. So in this case, this would be a pouch, that would be a pouch, that would be a pouch, and that would be a pouch. So I have 4 groups of 4. When we group, we're dividing. I'm going to use a fraction bar. So x equals 4. Usually we want to check our answer because it's easy to make mistakes, especially once we get to some more challenging equations with fractions and decimals and negative numbers. So to check, we could just pretend that there's 4 coins there, right? So this is 4, and this is 4, and this is 4, and this is 4, and count them up. So if we had 4 groups of 4 plus 2, is that going to balance out with 18 coins? Kind of like we did when we were trying to figure out if our solution made a true statement. Pretty similar, actually. The same. So 4 times 4 is 16, plus 2, is that equal to 18? Yup. We must have done it right. Okay, I'm going to flip to one of the harder ones, where they give you an equation to start with. So this is number 9 on your ACE problems. I'm going to do, looks like D, looks like a good one to do. It says for each equation in problems, A through D, sketch a picture using pouches and coins. Then determine how many coins are in a pouch. Finally, check your answer. So if we're looking at D, 10 is just, we know what it is, so that would be like having 10 coins. 4, 5, 6, 7, 8, 9, 10. Equals 2 X's, or 2 groups of X. Let's see if I can draw a pouch.
A couple of your print jobs have errors on them down there. I'm not sure what it is, but they're trying to deal with it.
Oh, thank you. I'll run down there. So 2 pouches and 1, 2, 3, 4 coins. So if we wanted to determine how many coins were in each pouch, we'd probably take off 4 first. So remember, we're like on a teeter-totter. That would keep it balanced. So in our equation, we took off 4 here and took off 4 here. So we've got 6 equals 2 pouches, because there's 6 coins left here and 2 pouches here. Well, then we can group it into 2 groups. So each group is going to have 3. So we divided it into 2 groups. So each group has 3 coins, or x equals 3. To check our answer, we want to put 3 in each bag and make sure there's really 10 on each side. So 3 plus 3, 6 plus 4, 10. Or if we want to use our equation, 10 equals 2 times 3 plus 4. 2 times 3 is 6, plus 4, 10 equals 10.